what we've got here is just a quick sort of 3D model of what the CNC axis sort of looks like. So we've got the saddle with the linear rails and the ball screw, and then obviously the bearing block. So what I'll do is let me just cut this in half, and move in on the bearings. So the slop was coming from the fact that the inner race and the outer race in the bearings can actually slide sort of in and out. It's really, really small. It's almost imperceptible, but it's enough that it can give mechanical systems backlash. So if I just grab the pulley here and rotate it ever so slowly, what you can see is that that inner race gets pushed first. Then if I go the other direction, in and out, the ball screw joint and ball screw and the inner race moves before the actual bearing block moves. So it's that play between the inner race and the outer race that was giving us that slop. Now, if I go to a shimmed arrangement, again, I'll just cut this in half. So what this shim does is it presses the inner race of the bearing out this way, and it presses the inner bearing of the race of this bearing out this way. And so that removes the ability for these races to move with the ball screw whilst the bearing block doesn't move. So the ball bearings are primed this way and then this way. So if I scroll out again, just grab that pulley, then there's no slop because these are pressed and fixed in place. So basically that's where the slop was coming from. But now it's everything shimmed, we should be good to go. Now I'm fully aware that this explainer might make it seem as though I know what it is that I'm doing, but I still really have no idea what it is that I'm doing. So we continue in ignorance, always.